Welcome to the exciting world of Python programming and artificial intelligence. In this journey, we'll explore the fundamental concepts of loops and functions and how they empower us to build AI applications. Imagine having a tireless assistant capable of performing repetitive tasks with incredible speed and accuracy. That's the power of automation, and that's what we'll unlock using Python loops. Loops are the workhorses of programming, allowing us to repeat instructions multiple times. This is crucial in AI, where we often deal with vast data sets and complex computations. In Python, we have two primary types of loops: for loops and while loops. Each type serves a specific purpose, providing flexibility in how we automate tasks. For loops are particularly useful when you know in advance how many times you want to execute a statement or a block of statements. They excel at iterating over a sequence of items, such as a list of numbers or characters. Think of for loops as counting machines. They are perfect for tasks like iterating over arrays, lists, or any other iterable objects. For example, if you have a list of student names and you want to print each name, a for loop is your go-to tool. On the other hand, while loops are conditional repeaters. They continue executing a block of code as long as a certain condition remains true. This makes while loops ideal for scenarios where the number of iterations is not known beforehand. For instance, you might use a while loop to keep asking a user for input until they provide a valid response. Both loop types play a vital role in AI, enabling us to process data, train models, and generate predictions. In data science, for loops can be used to iterate over datasets, while loops can manage tasks that require repeated checks and balances. Let's delve deeper into each type with illustrative examples. We'll explore how for loops can simplify repetitive tasks and how while loops can handle more complex condition-based operations. By mastering these loops, you'll unlock new levels of efficiency and capability in your Python programming journey. Imagine you have a basket of fruits and you want to inspect each fruit individually. You might want to check if they are ripe or if any are spoiled. This is where the concept of a loop comes in handy. In Python, a for loop can help you automate this process. For example, consider the following code: fruits equals sign, apple, banana, cherry. For each fruit in the list, the loop will execute the print fruit statement. In this example, the for loop iterates through the entire list of fruits. During each iteration, the variable fruit takes on the value of the current item in the list, one at a time. In each iteration, the variable fruit is assigned the value of the current fruit being processed. The code then prints the name of each fruit to the console one by one. This simple example demonstrates the power and efficiency of using loops in processing sequential data. Instead of manually writing code for each fruit, the loop handles it for you. In the field of artificial intelligence and data science, we often use loops to iterate over large data sets, which can contain millions of data points. These loops perform calculations or transformations on each data point, making it possible to analyze and process vast amounts of information efficiently. Whether it's cleaning data, training models, or making predictions, loops are an essential tool in the data scientist's toolkit. Understanding how to use loops effectively can greatly enhance your ability to write efficient and powerful code. So the next time you have a repetitive task, think about how a loop can simplify your code and save you time. Mastering loops is a fundamental step in becoming proficient in programming and data analysis. Now, let's say you want to keep filling a glass of water until it's completely full. This scenario calls for a loop, where the condition is the water level reaching the brim. Python water underscore level equals sign 0, while water underscore level 10, print filling, water underscore level equals sign, water underscore level plus 1, print glass full. In this code, the loop continues executing as long as the water level is less than 10. In each iteration, the code prints filling and increments the water level. Once the water level reaches 10, the loop terminates and the message glass full is printed. Loops are particularly useful in AI for tasks like optimization, where we repeat a process until a specific condition is met. For instance, we might use a loop to train a machine learning model until it achieves a desired level of accuracy. Functions, the building blocks of code. As our programs grow in complexity, it's crucial to organize our code into manageable chunks. This is where functions come into play. Think of functions as specialized tools in a toolbox. Each tool serves a specific purpose, and we can reuse them whenever needed without rewriting the same code repeatedly. In Python, we define functions using the keyword, followed by the function name and parentheses containing any input parameters. The code within the function block defines its functionality. The significance of functions in AI. Functions are essential in AI for several reasons. They promote code reusability, making our programs more efficient and easier to maintain. Moreover, functions enhance code readability, allowing us to break down complex tasks into smaller, more understandable units. In AI, we often use functions to encapsulate specific operations, such as data pre-processing, model training, or prediction generation. This modular approach simplifies the development and debugging of AI applications. Now that we've covered the foundations of Python programming, let's explore a powerful AI library called TensorFlow. TensorFlow provides a vast collection of tools and functions specifically designed for building and deploying machine learning models. With TensorFlow, we can create complex neural networks, train them on massive datasets, and use them to make predictions on new data. Let's illustrate its usage with a simple example. Imagine we want to train a simple AI model to recognize handwritten digits. This is a fundamental task in the field of machine learning and artificial intelligence, often used as a starting point for beginners. We can use TensorFlow, a powerful open-source library, and loops to accomplish this task. TensorFlow provides a comprehensive ecosystem of tools, libraries, and community resources that lets researchers push the state-of-the-art in machine learning. First, we load the MNIST dataset, which contains thousands of images of handwritten digits. This dataset is widely used for training and testing in the field of machine learning and is a great resource for developing and benchmarking new algorithms. Then we create a simple neural network model using TensorFlow's Keras API. Keras is a high-level API that allows for easy and fast prototyping, making it accessible for both beginners and experts. The loop iterates over a specified number of epochs, training the model on the training data in each iteration. Each epoch represents one complete pass through the entire training dataset. During training, the model learns to recognize patterns in the handwritten digits. It adjusts its internal parameters through a process called backpropagation, which minimizes the error in its predictions. Finally, we evaluate the trained model's performance on the test data, measuring its accuracy in classifying unseen digits. This step is crucial to ensure that the model generalizes well to new, unseen data and doesn't just memorize the training examples. The applications of AI are vast and ever-expanding. From self-driving cars to personalized medicine, AI is transforming various industries and aspects of our lives. In healthcare, AI is used to diagnose diseases, develop new treatments, and personalize patient care. In finance, AI powers fraud detection systems, algorithmic trading platforms, and customer service chatbots. The possibilities are limitless, and as AI technology continues to advance, we can expect even more groundbreaking applications in the future. Congratulations on taking your first steps into the world of Python programming and artificial intelligence. You've learned about the fundamental concepts of loops, functions, and AI libraries like TensorFlow. As you delve deeper into AI, you'll discover a universe of possibilities. Embrace the power of automation, explore advanced AI algorithms, and contribute to the development of innovative solutions. Remember, the journey of 1,000 miles begins with a single step. Keep learning, keep experimenting, and let your curiosity guide you as you embark on this exciting adventure.